Hey geometry students, it's Mrs. Fellon. I'm actually going to start this lesson. This is going to be the lesson for lesson 3.3. But we are actually going to start with some construction. We're going to construct parallel lines. So what I need you to grab right now, if you don't already have it, is a piece of paper. So just a plain piece of paper would work, or a piece of notebook paper, and then a compass and a straight edge. So pause the video, go grab those, and then come back. All right, welcome back. What we're going to do is I'm going to show you how to do a construction. We've been talking a lot about parallel lines so far. So what I want to show you is how to actually construct it using some of the geometric tools that we have. All right, so we're going to construct a parallel line from a point to a line. So the first thing I want you to do is I want you to draw, using your straight edge, just draw a line. So I'm just going to draw a line, and I'm going to put a point somewhere. I'm going to call it P. Point P. So it doesn't really matter where your line is, or how long your line is, or even where your point is located. The first thing I want you to do when we're going to do this construction is I want you to extend. So see what I'm going to do is I'm going to go ahead and connect this from a line from this point to this line that I drew. So I'm going to extend it above. So I want it to kind of extend past it because I need a little bit of extra space up here. And then obviously I want it to hit this line at the bottom that I drew. So I'm going to call this line M. So now our next phase is, if you remember the video on copying angles, we're actually going to use that method to help us construct parallel lines. So when you copy at an angle, so do you see how this forms an angle down here? We're going to copy that angle up here. So what I'm going to do is I'm going to set my compass on that vertex. So kind of right where that intersection of those two lines are. I'm going to pick a measure. I want something that's going to fall before point P. So I'm going to pick one of my dots here. Like I'm going to pick G. And what I'm going to do is I'm going to make an arc. So remember that it's G. So I'm going to write down G so I don't forget. And what I just did is I picked G, and again, it could be any of them, as long as it falls between, like it can't go past point P. And I just want you to draw an arc that intersects both this line and this line. So we'll call this line L, and we'll call that line M. So your arc is intersecting both line L and M. Okay, so now that you've done that part, what I want you to do is I want you to do the exact same thing up here. But this time I want you to put your compass at point P. And then I want you to find I used G, so I'm going to put my pencil in G, and I'm going to make another arc. Notice that I didn't make my arc, like I didn't go make a whole circle. You can. I just wanted to make it far enough so that so I don't have to redraw it. So like I did kind of almost like a half circle. I would encourage you to go, if you're at all worried, I would encourage you to draw more than less, because that way you've already moved your compass and it just increases your chances of error. All right, so all we did here was kind of make an arc, and then we copied it up here. Next step, we are going to measure how wide this angle is. So let's call this, see these 2 points here, A and B. So I'm going to measure points A and B. So I'm going to take my compass, and it doesn't matter if you start at A or start at B, and I want to measure how long. Let's see here. Mine looks like it's at D. Now yours obviously is different because we're all going to draw ours a little bit different, but mine's at D. So I'm going to make a little note of that on my paper just so I don't forget. So I measured how wide the angle I made, and it was like on my compass, it was length D. So now I'm going to go up to this intersection point. I'm going to call that one C. So I'm going to slide my compass up here, put my finger on it so it doesn't move. I'm going to find D, because that's what I used. And I'm just going to draw an arc so it intersects my other one. So what I'm looking for is this kind of a scenario. I want this little X marks the spot, so to speak. So all I did was measure how wide this angle was, and then slid my compass up here to that intersection point at the top, and then marked off that exact same distance. Now, you take your X, and you take your point P, and you make it as parallel as you can, and you draw in your line. So now, this line is parallel to that line, and that's how you construct a parallel line. This one is probably one of the tougher constructions. I'm just going to be honest with you. I've taught geometry for many years, and this one tends to be a tough construction. I would make sure that you can do this construction without like on your own, right? So without watching the video. I would practice with the video a couple times, and you could keep, you can keep doing this as many times as you need. If you want to write down steps, as you guys go through them, great. But you're going to need to be able to do this like kind of cold, so to speak. So without any notes, without any video or whatever. So you will be expected to kind of know how to do these constructions. All right, well, that's the only construction we're doing so far today. So we can put away our constructions. I would keep them in a nice safe place so that you don't lose them. All right, I am going to find page 78. It's right here in my student journal. And so if you notice on page 78, there's lots of vocab, of course, because we love vocab, but it's all review. Remember Converse? That was when we talked about in Unit 2, we talked a lot about like the converse of a statement. So that was like the opposite. So remember converse, and if it was like P implies Q, the converse is Q implies P. It's like the other order, right? Parallel lines again, we already know that one. Transversal, we know that one. So again, two parallel lines cut by a transversal. Corresponding angles we know alternate interior, alternate exterior, consecutive interior, and the word congruent. So again, all of this is not something we need to kind of go over again, but again, just as a reminder, those kind of exist. All right, now I'm going to have you switch gears again. So I apologize for all the jumping around, but I want you to find that postulate theorem page that we've been working on. We're going to add some additional theorems to it. So this is my page. We left off on the consecutive interior angles theorem, which we finished. Fantastic. And so now we are going to do all of the converses. So converse, 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 converse. So we're going to do 4 different theorems, but you will notice they're pretty much the same theorems we already did. Corresponding angles theorem, but we're doing the corresponding angles converse. Alternate interior angles, converse. So let's think about what we think a corresponding angles theorem would be, right? If 2 lines are cut by a transversal, then the pairs of corresponding angles are congruent. So what a converse is. If is the P part, and the then is the Q part. So if 2 lines are parallel, then the corresponding angles are congruent. Well, then if we're going to do the converse, it would be literally the opposite of that, right? So now we're going to do Q implies P. If 2 lines are cut by a transversal so that corresponding angles are congruent, it's kind of a mouthful, then they're parallel. So basically what we're using all of these converse theorems here for, we're using them to prove lines are parallel. And so that's what these converse theorems do. Whereas the other theorems kind of proved that corresponding angles are congruent, or that alternate interior angles are congruent, and so forth. These 4 theorems prove that if those things occur, then the lines are parallel. So in your proofs, as we get to writing proofs in the next few units, or next few lessons, you're going to want to think about what your goal is. If your goal is to prove lines are parallel, then you're going to probably use a converse. If you're trying to prove that corresponding angles are congruent, then you're going to use the regular theorem. So let's go ahead, and there's not a whole lot to write about this, but basically what they're saying is if you have 2 lines cut by a transversal and you know that corresponding angles are congruent, so I'm going to say 1 and 2. I'm going to do the little congruent symbol. So remember how we did with angles, we use the same markings? What this then proves is L is parallel to M. So again, if we know corresponding angles are congruent, then lines are parallel. All of these are done the same way. If I have 2 parallel lines and are cut by a transversal, then I know that and I have alternate interior angles are congruent. So 1 is congruent to 2, then my lines are parallel. Alternate exterior. So if I know 1 is congruent to 2, then my 2 lines are parallel. And then finally, consecutive interior. This one actually is kind of the different one, right? So if we know that these 2, they're not congruent, but they're supplementary. So this one states that if we know that the measure of angle 1 and angle 2 add up to 180 degrees, right? So we know, so we could say angle 1 and angle 2 are supplementary. That means they add up to 180 degrees. Now we know that my two lines are parallel. Okay, so those are all the theorems, or at least those first ones. We are going to do a couple more. So those were all the converse ones. Now let's talk about a couple extra ones. So if you notice, the last one on this page says transitive property of parallel lines. So remember the transitive property? That's like if A equals B, so I'll write it down. If A equals B and B equals C, A equals C. So basically, if two things are equal to the same thing, then they're equal to each other. Same thing goes with parallel lines. If two parallel lines, so let me say that again. If two lines are parallel, same line, then they are parallel to each other. So imagine you have a line, right? And you have two other lines. So this line, oh, I'm parallel to this line. And then you say, well, also parallel to this line. So that means these two lines have to be parallel to each other. So you can't have this line parallel to this line parallel to this line, and then these two lines not parallel to each other. That's what they're kind of getting at. So that's that property. It's that transitive property, but this time we're talking about parallel lines. So it's a little bit different, obviously. All right, let's do a little practice. So I'm going to put this away. I'm going to go to page 80 of your student journals. We're going to kind of skip over the other stuff because we just talked about them. And then I'm going to show you how we're going to use some of this stuff. All right, let's do the math. All right, so it says find the value of x that makes these lines parallel. So in order for these lines to be parallel, what do we have to know about these two sets of angles? Well, first, again, what kind of angles are they? This one's in the, I guess, bottom right of this set of four, and this one's in the bottom right of this set of four. That's because they're corresponding angles. So if we can show, so what we're going to say is what value of x makes these two lines parallel. In other words, what value of x causes 95 to equal 8x plus 55. So we want to show that these are equal because they're corresponding, and we want to find a value of x that makes that true. So I get, if I subtract 55 and then divide by 8, I find out that x is 5. All right, on this one, in order for these lines to be parallel, what kind of angles are these? These are alternate exterior angles, okay? Alternate exterior angles. And in order for these lines to be parallel, these two sets of angles have to be equal. In other words, they're congruent, but their measures are equal. We're going to set those equal to each other. I'm going to subtract 200, and then I'm going to divide by -2. I get x to equal 35. All right, says decide whether there is enough information to prove that M is parallel to N. If so, state the theorem you would like to use. If we know those two angles are congruent, so what kind of angles are these? So the first thing I would look at is, well, this is in the bottom right, and this is in the bottom right. Oh, good, they're corresponding. So do we have a theorem that says if corresponding angles are congruent, then lines are parallel? We sure do. So this would be the corresponding angles converse. So corresponding angles converse. Remember, the converse is the one that's proving lines are parallel, so that's why we're using this one. All right, what kind of angles are these? Well, they're across from each other, so again, we should know that they're vertical. Do we have a theorem that says if two angles are vertical angles, then lines are parallel? No, not that I recall. I don't recall writing that down, do you? So this one is not enough info, because we don't know enough on this one. So what they have marked is not enough for us to be able to determine that those lines are indeed parallel. All right, what do we have with this one? Well, we have vertical angles, right? So we got a lot of stuff going on here. Let's just make sure. Yeah, all I see are vertical angles, and we already said that that's not enough. So not enough info. And then last but not least, this angle and this angle. So I want you to kind of imagine, they're throwing you off here a little bit, which is good because I want you to practice some that are a little bit harder. But it's almost like this line doesn't really matter. And so if we're trying to show that M and N are parallel, we don't really care about S. So I'm just going to kind of scratch it out because I'm going to try to not think about it. All right, so what kind of angles is this one and this one? Well, if this is the interior of M and N, right, so between them, then these are alternate exterior angles. And if we can show, and if they're congruent, then we know lines are parallel. So this would be the alternate exterior angles, converse. All right, that is it for this video. Go ahead and try some practice on big ideas. As always, bring any questions or concerns about the video to your teacher, and they will hopefully clear up any misconceptions you might have. All right, bye guys.